Hi, my name is Raina Grosswald, and I will be talking about kinetics. And I made this presentation with my friend Abigail Abdi. So first, we are going to start with the SL topics of HL chemistry kinetics. So the first concept is energy level diagrams. In energy level diagrams, we have electrons that move from the ground state to a higher state in an energy level, or an excited, also known as an excited state, by absorbing energy. And then electrons that absorb less and less energy as they move towards ionization. As electrons move from the excited state to the lower energy levels and eventually get to the ground state, they do so by releasing energy. Lastly, electrons release more and more energy as they move towards the ground state. So in the diagram shown on your right, this is what it looks like for electrons to move when they are surrounding a nucleus. The next concept we have is collision theory. Collision theory states that molecules react when they collide into each other with enough force, speed, and at the correct orientation to start a reaction. Increased temperature, smaller volumes, high pressure, and high concentrations all increase the number of collisions that occur between molecules, and as a result, the rate of reaction increases. The increase in temperature resulting in faster molecular movement is called kinetic theory. The frequency factor A takes into account the frequency of collisions with proper orientation. The next concept is kinetic molecular theory. This theory states that the particles and gases are rapidly moving in random motion, have negligible volume compared to the gas volume, exert no forces on each other, collide elastically with each other and the container walls, and have an average kinetic energy that is directly proportional to the absolute temperature of the gas. You can see the molecules moving with their kinetic energy in the container shown in the image below. And lastly, increasing the temperature of a gas increases the average kinetic energy of the particles. It also increases the range of velocities of the particles. The next concept is rates of reaction. The definition of a rate of reaction is the change in concentration of a reactant or a product with time. Units are molarity per second, which also means concentration per second. Some of the factors that can affect the reaction rate are temperature, which can affect because of the collision theory and kinetic theory. Concentration of reactants. This can affect it because a higher concentration leads to more collisions if there is enough energy present. Catalysts could affect the rate of reaction. It could speed up the reaction by lowering the activation energy, which is the amount of energy it takes for a reaction to occur. And it can provide a shorter path for molecules to take to activate. Catalysts do not undergo the reaction themselves, however. They only speed up the reaction. The next factor is surface area of a solid reactant. It's known as the bread and butter theory. More area for the reactants to be in contact increases the surface area, which means there's a higher rate. So if you have one large particle or 5 smaller particles, the 5 smaller particles will have a faster reaction rate because there's more surface area present. And lastly, pressure of gaseous reactants / products can also be a factor. If it can increase the number of collisions, because an increase in pressure increases the number of collisions, which will then increase the rate, as we talked about with collision theory. Okay, so our next concept is the rate order. And when talking about the rate order, it's the coefficients of a theoretical equation that are and they become the exponents of the concentrations of elements in the rate expression, and the sum of the exponents determines the overall rate order. However, the rate equation can only be determined experimentally. So you can have theoretical equations, but your real rate equation won't come unless you actually do the experimentation. So when talking about the orders, there's different classifications. So the zero order is when the concentration changes, but the rate of the equation stays the same. In other words, the exponent is zero overall. The first order is when both concentration and rate order and the rate change by the same amount, as in they change by the same factor. And this also means the concentration would have an exponent of 1. The second order, which is when the concentration doubles and the rate is squared, which means that there is a quadrupling of the concentration. So basically the concentration increases by the squared amount that the rate increases. And lastly, the third order, which is not as common as the other three, is when the concentration triples and the rate is cubed. So here is an example of the rate order. So you can read the question, and I'll give you some time. You can pause the video right here and do it on your own, and then when you're done, I will explain the answer. Okay, so now that you have completed the question, let's see. So it says nitrogen monoxide gas, a product of the reaction above, can react with oxygen to produce nitrogen dioxide gas as presented below. And there is an equation. It says a rate study of the reaction yielded the data recorded in the table below, and this table. So determine the order of the reaction with respect to each of the following reactants. Give details of your reasoning, clearly explaining or showing how you arrived at your answer. So we have the two reactants listed, NO and O2. So for NO, comparing experiments 1 and 3, which you have to compare 2 experiments in order to come up with an answer. The order in NO is equal to 2 because the rate was squared and the concentration was tripled. So, which means that, like we said, the one was squared and one was tripled, as it was mentioned on the slide before. And then when talking about O2, we compared experiments 1 and 2 because you have to find one constant between the two. And it says the order is 1 because the rate and concentration increased by the same amount. And so to get the total order, you have to add the two numbers. So 2 plus 1 equals 3. And that should be your answer. Or the third order should be your answer. The next concept we have to talk about, which I briefly mentioned it earlier, is activation energy. This is just a basic concept to understand how reactions work and in terms of like catalysts and things like that. So the definition of activation energy is the minimum amount of energy required to initiate a chemical reaction. And then the activation energy can be lowered with a catalyst, which is a compound that speeds up a reaction by lowering its activation energy. So as you can see in the diagram, this is a reaction graph. It's an enthalpy graph, and it shows the reactants and products always stay the same, but the activation energy can move higher or lower depending on if a catalyst is involved. And just like we mentioned before, if a catalyst is involved in the reaction, it does not undergo the reaction itself. Its sole purpose is to speed up whatever reaction is occurring. All right, the next concept is Maxwell-Boltzmann energy distribution curve. So this is a complicated graph that is involved with this idea of kinetics. So the curve shows distribution of particle velocities in a gas. At lower temperatures, the gas has less energy and less speed and a greater number of particles. As temperature increases, the curve flattens and speed increases while the number of particles decreases. So you can see in the graphs listed below how the concepts I just discussed work with the graphs. You can pause the video if this is moving too fast for you also. And that is the end of our SL topics. So click on the next video to look at our HL topics.